So we've talked a lot about modern tools. What about the timing of these? Interesting. We'll save that for later, but I want to talk about performance of a program. We have a couple different programs here to explore. We have time, we have perf, and we have hyperfine. Well, being introduced to programming from the Python side of things, I know how to time things in Python, right? You just -m, you time it, or if you're in an IPython session, you get the %time magic out, or %time it magic out. It is very easy. But what if I don't want to time just Python? What if I want to time something else? We can use the time function, time command in order to time anything. Right? In this case, I'm still timing Python, but I can use it and I get the output. I can see that it spent 0.2 seconds in user and 0.1 seconds on the system using almost no CPU, and that's because all we did was sleep. Let's do something that's a little bit more process heavy here. What if we, instead of just sleeping, we sum up all of the values from 1 to 1,000,000, not inclusive of 1,000,000, right? That's how range works. So now we can see our CPU shot up. We did this relatively fast, and we were able to time it just from the command line. Nice interactively. Didn't have to change anything in my Python code in order to do this. But can we get more information, right? Just seeing how long it spent on both the user and system, that's cool. But what if I really want to get some real benchmarks that I can report? Well, this is where hyperfine comes in. What runs faster, sleeping for 0.1 seconds or sleeping for 0.5 seconds? Well, obviously sleeping for just 0.1 seconds, and it'll actually time both of these. This output, very modern, sleek, I love it. Got the colors, you have the visual separation between the two benchmarks, and then it summarizes it at the end for you. Sleeping for 0.1 seconds ran about 5 times faster. Why is it about 5 times faster? Well, hyperfine works very similar to Python's timeit, where it will run the same function calls or the same tool or command line call multiple times, and it will extract the average time and the standard deviation of that time, as well as the range of min and max for all the runs that it did. And then it'll give you that nice summary of comparison of your averages. So I really like hyperfine. I think it's a great tool if you want to examine how long something's running, and if you want to benchmark it and compare it to other tools. It's very, very neat. And then we have perf. What if we want more fine-grained information? What if just knowing the time is not enough? I want the number of CPU cycles. I want the number of machine instructions that were given. We can see here, perf, okay, there's a lot of output here, right? This is what, a billion cycles? 5 million instructions or 58 million instructions? That's a lot. What did we do here? All we did was Python 3-C 1+1. Okay, the thing about perf is that it's not great for testing very high-level scripts or high-level programming languages in general, because you're very far away from the metal, and perf tests very close to the metal. If I was testing something written in C, C++, we would have much better control over all of the output that perf has. And I can show you that even within Python. If I add -s to my Python call flag, we can see that the number of cycles decreases, the number of instructions decreases, and everything looks like it just ran with a little bit less or a little bit faster. And what this means is that the -s flag did something in order to reduce the CPU load. All -s does is it tells Python, hey, start up with the minimal modules needed in order to run the interpreter. I don't want you automatically importing some of the frozen modules like RE or anything else. Give me the bare bones. Give me the sys, the OS, and the like, right? So if you don't start Python with this -s flag, you'll automatically have preloaded in a lot of modules that you may or may not end up using. And And perf allows us to track that, right? And we can actually see the visible change in our perf output just by adding the -s flag. Lastly, I want to address hopefully a long-standing question. Is modern really any faster? In this example, we'll be using hyperfine, a modern tool, to compare or create benchmarks for common commands. So here we'll be comparing exa to ls. And we can see in our output, I'm not super thrilled about it, but we can see that ls ran a little bit faster. 1.21 times faster. Specifically, we're talking about the difference between 16 milliseconds and 13 milliseconds. I don't know. I think 3 milliseconds is worth the wait in order to get some really nice output, really nice colorized or tree-like output. So in my opinion, even though it's a little bit slower, exa still takes the cake for me. What about cat versus batcat? And I even included the -pp flag for batcat in order to ensure we're not paginating and to get rid of all of the colors. So that's not really bogging down our output here. Well, we can see that cat is way faster than batcat. Batcat might still be trying to do some of that syntax highlighting under the hood. There's probably a couple more flags I could add in here to pare it down even further. But overall, if all you want to do is just concatenate some files on top of each other and you want to do it quickly, cat is still your go-to. Next, we have ripgrep compared to egrep. And this is going to be a very interesting output. I've used the ripgrep-UUU flag in order to pare down a lot of its extraneous features and behave most similarly to egrep. And we can still see that the egrep was almost 5 times faster. And now we're comparing 28.7 milliseconds to run ripgrep compared to 6 milliseconds from egrep. That's kind of a big difference. But I do want to comment that this might not be the best comparison because the file system we're exploring, right, we're looking for all the file.txts, and the file system we're exploring isn't that large, right? So we have a very limited search space. One thing that ripgrep is by default is it's multi-threaded. That means you get a lot of overhead in order to start the threads that it wants to use. And so that could be something that's interfering with our timing, right? It's not that the search is slow, it's that it just takes a little bit longer to start up. And then once it's started up, maybe if we had a bigger file system to navigate, we would have a very fast throughput. Lastly, fdfind, searching for all of the JSON files in our example folder versus find. Which will be faster? This should be a close one. I liked fdfind a lot. I think the syntax is more intuitive than find. Is speed the name of its game, though? 54.6 milliseconds compared to 28.9 milliseconds. It might not be as fast as find, but I'll still take its output, honestly. I will take the ease of input, ease of output. If I'm writing something that's machine critical, I'm probably not searching or something that's time critical, I'm probably not searching my entire, folder of whatever in order to locate some specific files. If it's really time critical, I'll know the location of those files in advance, so I'm not too concerned with the timing output here. I personally like FD a lot, and just for its verbosity. So to wrap up my final thoughts here on this question, I really like hyperfine. I think it's better than time, and it's a little bit different than perf, right? So perf has that fine-grained, low-level information on process usage, whereas hyperfine and time really are just for measuring how long did this take. Hyperfine is fantastic in that it gives you multiple runs and gives you multiple benchmarks in a very easy-to-read way. And it'll even summarize that information for you. It'll test, you can test things like the same script with different parameters. You can test against different scripts who have the same purpose, like we just did, comparing the modern tools to the older tools. And you can even do things like tests against different Git branches, right? Did it run faster on version 1.1.2, or was it faster on version 1.1.1? And if it was faster than the old one, why do we have this performance regression? So tools like hyperfine are fantastic in order to measure how fast your code is executing, and especially for Git, Did we accidentally introduce a bug that slowed things down? And so that wraps up our question. One last final departing thought. What about memory usage, right? These aren't profilers that we're talking about. A lot of them are timers. Perf, more of the profiling aspect. But none of these tools really deliver anything on memory usage or consumption. So just some final food for thought as we depart here. Thank you so much. This brings us to the end of today's session. I had a blast walking through modern tools and comparing them to the old ones. Hopefully you've picked up some modern tools that you will start using on your own. I know I have.